Opposite sides are parallel. Number one property of parallelogram. Correct or full spelling, parallelogram. Number one property, opposite sides are parallel. Opposite sides are parallel. Number two, opposite sides are equal. Opposite sides are equal. Number three, opposite angles are equal. Then number four, diagonals bisect one another. Diagonals bisect one another. Let's quickly show all of this. The first one says opposite sides are parallel. This side, let me label it A, B, C, D. Side AB is opposite to side DC, and both of them are parallel and equal. Opposite sides are equal, opposite sides are parallel. Please don't forget. So if I say this one is 5, or say 4, then this side is also 4. If I say this 4 cm, this one is also 4 cm. They are parallel and they are equal. Again, another property of parallelogram is that opposite angles are equal. So if this is x, then this is x. If this is y, this is y. Both of them are equal. Again, the last property of parallelogram, it says the diagonals. This is what we mean by diagonals. This diagonal cuts this diagonal into two equal halves. Then this diagonal also cuts this one into equal halves. So if this one is 5, this one is 5. If this one is 6, this one is 6. Because the diagonals bisect each other. Sorry. It's not one another. When you're dealing with two things, it's each other. When you're dealing with more than two, you use one another. Diagonals bisect each other. That is the property of parallelogram. Again, let's quickly look at rhombus. This may come in your objective question. This may come in your objective question. Look at this. I'm sure you've seen a rhombus before. But if not, this is an opportunity to look at one. A rhombus looks like this. All right? This is right angle. Number one, all four sides are equal. This is the rhombus. All four sides are equal. Number two, opposite sides are parallel. Opposite sides are parallel. Number three, opposite angles are equal. Opposite angles are equal. Again, diagonals bisect at right angles. Number four, diagonals, these are diagonals. They bisect at right angles. Diagonals bisect at right angles. Diagonals bisect at right angles. Number five, Diagonals bisect the angles. Diagonals bisect the angles. Okay, let's quickly look at that. Number one, all four sides are equal. This side is equal to this side, is equal to this side, is equal to this side, which means if this one is 2 centimeter, this one is 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. That's the meaning. Number two, opposite sides are parallel. This side is opposite to this side, and it means again is parallel to this side. If you look at this side and this side, they are opposite. It means again it is parallel to this side. That's number two property. These are properties. Properties of rhombus. Number three, opposite angles are equal. These are opposite angles. This is an angle. These two angles are opposite. These two angles are opposite. And number three property is telling us that if this one is 50, this one is 50. If this one is 130, this one is 130. Opposite angles are equal. Number four, diagonals, they bisect each other at right angles. This one, the diagonal is coming, and another diagonal is coming the opposite way. They bisect. In other words, this side is equal to this side is equal to this side. Again, they are bisecting each other at right angles. So the angles on each of those lines are 90, 90, 90, which gives us a total of 360. Then lastly, diagonals bisect angles. So if I tell you that the angle here is 50, what this means, if this diagonal is coming down, what this means is this is 25, this is 25. Diagonals bisect the angles. That is that about parallelogram and rhombus. Now, a polygon. A polygon is any plane figure with straight sides. A polygon is any plane figure with straight sides. A regular polygon has angles and sides of equal size and length. Pentagon, for instance, has 5 sides, and the sum of the angles is gotten by a particular formula. Let's quickly look at the names based on the sides. The name of the sides of a given polygon is what determines the number of sides he has is what determines the name that he bears. Cut. Alright, these are the various names based on the number of sides. Any shape with 3 sides is called a triangle. We've already treated the various types of triangles. All you need to do is to check the catalog of the topics, and then you can quickly educate yourself on the types of triangle we have, how to calculate the area and all that. Number 4, any shape with 4 sides is called a quadrilateral. Again, we have treated extensively the basic quadrilaterals. We have the square, we have the rectangle, we have the parallelogram, the trapezium, we have the rhombus. We just treated that shortly back. Again, shapes with 5 sides are known as pentagon. A shape with 6 sides is hexagon. Then heptagon for 7 sides, octagon for 8 sides, nonagon for 9 sides, decagon for 10 sides, and dodecagon for 12 sides. Now, to calculate the sum of the interior angles, this is the formula that is used. This formula is used to calculate the sum of interior angles. 2n minus 4 into 90 degrees, where n is number of sides. This is the formula for calculating sum of interior angles of any polygon. 2n minus 4 into bracket 90. Again, the exterior angles of a polygon all polygons, the sum of the exterior angles, I need to say this, the sum of the exterior angles of all polygon, let me put it in capital letters, that you will know how important it is, all of all polygons equals 360 degrees. Don't forget, the sum of the exterior angles of all polygons is equal to 360, but the sum of the interior angles is calculated using this particular formula. I'd like us to take a few questions so that we can get ourselves used to the way this thing works, and then we can move on to other things. All right, quickly let's take a question and get ourselves familiar with this. Now look at it. This question says two of the exterior angles of a polygon are 63 degrees each. The remaining exterior angles are 26 degrees each. How many sides has the polygon? How many sides? All right. To answer that question, we are told two of the exterior angles. So we have 63, and then again we have, the question says the remaining exterior angles are 26 degrees each. So we have 26 times x, since we don't know how many sides the polygon has. So for us to answer this question, we have 63 plus 63 plus 26x equals to 360. And like I've told us, I said the sum of the exterior angles of all polygons is equal to 360. Again, if you add these together, you have 126 plus 26x equals to 360. Then you have 26x equals to 360 minus 126. Again, what you're going to have is 234. So 26x equals to 234. If you divide both sides by 26, you will discover that 234 divided by 26, if you use your calculator, will give you 9. So that means 26 in 9 places plus this side. Each side will have an exterior angle. So this is 1, this is 2 plus 9. So we have 1, 2 plus 9. 2 plus 9 will give us 11 sides. The polygon has 11 sides. The polygon has 11 sides. All right, let's quickly go to trigonometry. All right, pause. All right, before we go to trigonometry, I stumbled on two different things in my note, and I also think you want to learn it. The perpendicularity of a tangent and a radius. A tangent is a line that touches a circle at just one point. If this is the center of the circle, okay, line AB will be a tangent if it touches this circle just at one place. Now, what this concept is saying, or what this theory is saying, is the tangent AB to the circle at T is perpendicular to the radius of that circle at that point T. This line that is tangential to this circle, it is perpendicular to the circle, or to the radius of the circle at that point where it touches the circle at T. This will help you when you are also dealing with questions in circle theorem. If you are dealing with a question and you find out that they told you that line AB is tangential to a circle, and from the center of the circle you draw a line straight to the point of the tangent, you know that that radius is standing to that tangent at 90 degrees. So that is the advantage. What it's saying is the radius is perpendicular to the tangent. Radius is perpendicular to the tangent at the tangential point. Tangential. Please note this. Questions will present themselves. Nobody will tell you that, okay, this radius is perpendicular to the tangent. It is because you are well versed in circle theory. You know so many of the various concept theorems, principles, and then you'll be able to apply them. You'll be able to weave them into your own knowledge and use them to answer questions. And then finally, the angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. That looks rather confusing, but let me quickly explain to you. Look at this. Inside this circle we have a triangle. Inside this circle we have a triangle. This is X and this is Y. This is a tangent. It's a tangent PT. Tangent PT. This is Y. The whole of this place too is X. Now, what this principle is saying, we are done with this one. What this one is saying is this, that the angle between a tangent and a circle, the tangent to a circle, this is a tangent PT to a circle. The angle between a chord, this is a chord for instance. A chord is a straight line that is joining the circle at 2 points on the circumference. Chord, let's label it as A, B, C. Chord BC is making an angle X with the tangent PT. Chord BC, let me write it. Chord BC makes angle X with tangent PT. Look at it. Chord BC makes an angle X with tangent PT. The same thing with chord AC. Chord AC makes angle Y. Makes angle Y with the same tangent, with the tangent. Now, what this principle is now saying is this. The angle that is made by the chord and the tangent is equal to the angle in the alternate segment. This is the alternate segment. Look at it. This is one angle here, and this is one segment here. We are looking at another segment, this segment and this segment. The angle that is made here is equal to this angle. The angle that is made here between this chord and this tangent is also equal to the angle in the alternate segment. Again, we have a question that presents this. Anytime you see a tangent in a circle geometry, please look at it well. You will be able to apply the knowledge you have borrowed from, or the knowledge you have acquired from this information. The radius is standing perpendicular to the tangent to a circle, and then when a chord is making an angle with a tangent, the angle that it makes is equal to the angle in the alternate segment. That's what it means. And then when you read this information, when you are faced with questions, either in your objective or in your theory. Now let's move on to trigonometry, like I already said.